Number 7. The ionization energy for a hydrogen-like Bohr atom is 4 Rydbergs. What is the wavelength of the radiation emitted when the electron jumps from the first excited state to the ground state? And in the B part, it is asking what is the radius of the first orbit for this atom. So the energy of the electron in the hydrogen-like atom in the nth orbit is given by the expression En is equal to Z square Rhc upon n square. And from here we can say that Rhc is regarded as equal to 1 Rydberg. So we take this value is equal to 1 Rydberg. So now when the question is telling us that the ionization energy of hydrogen-like Bohr atom is 4 Rydbergs, so I can say that the value corresponding to E infinity minus E1 will become equal to Z square Rhc, which is equal to 4 Rydberg. So over here I can say that this Rhc is equal to 1 Rydberg, and hence we can say that Z square is equal to 4, and from here I can calculate Z is equal to 2. Now the energy required to excite from the first excited state to the ground state is asked. So I can say that the transition is taking place from E2 minus E1. The question is asking us the wavelength corresponding to this energy gap. So I can write it as equivalent to minus Z square Rhc upon 2 square minus Z square Rhc upon 1 square. So from here we obtain a value equivalent to Z square Rhc 1 minus 1 by 4, and we end up getting 3 by 4 Z square Rhc. So from here I can say that Z square Rhc is equal to 4 Rydberg. So Z square Rhc can be substituted to be 4 Rydberg, and we will obtain the expression in terms of that is 3 by 4 into 4 Rydberg. So we obtain it as equivalent to 3 Rydberg. So now I can say that if this is equivalent to the wavelength lambda, so I can equate this energy equal to Hc by lambda, and from here we can calculate the required wavelength, which is equal to Hc by 3 Rydberg. So this is the expression we are looking for. So if I calculate the value of wavelength, which is equal to Hc by 3 Rydberg, so H can be written as 6.6 into 10 to the power minus 34, C as 3 into 10 to the power 8 upon 3, and Rydberg can be written as 2.2 into 10 to the power minus 18. So from here we obtain a value which is roughly equal to 300 angstrom. So the value will be roughly equal to 300 angstrom, which becomes the answer to the first part. Now in the second part, the question is asking us to calculate the radius of the nth Bohr orbit. So the radius of the nth Bohr orbit is equal to R0 by Z, where we can write R0 as 5 into 10 to the power minus 11 upon Z. So the value of Z is previously calculated as 2. So I can put the value of 2 and obtain 2.5 into 10 to the power minus 11 meter. So this becomes the answer for the second part.